Hello, I'm glad to see you on the Codberry Club community meetup, and today we are going to talk about about Android, about modern Android development. And today our guest is Artem Bagritsevich. He is Chief Software Engineer Level 2 in EPAM. Artem.
Yeah. Hi. Thank you. I'm glad to be here. And yeah, we're going to talk today about modern Android development, but not about cutting edge. Let's say that if you will join some random Android project right now, then most probably you will see something like this, some code base like this. But if you want to know about cutting edge technologies, we can share this link about now an Android project created by Google. And in this project, you can find cutting edge approaches, Jetpack Compose, like composable UI, and a lot of different stuff. But today we are going to review this small application created by our students and mentors from Rolling Scopes School in scope of our course. And this is basically currency converter application. You can see a lot of different currencies, and you can see that it is sporadically updated and recalculated. Yeah, you can see that values changed. Also, we can select different currencies, and we can update. We can like set some value, and all currencies will be recalculated according to the value and to the currency rate we received from the backend. And today we're going to review how this application works. Yeah, pretty simple. By the way, Andrei, do you have some questions or comments regarding our talk?
So for now, it looks like pretty simple, and let's go to the next parts. And
Yeah, sure. Yeah, I would say it's not so simple. It can look simple on the first glance, but we have recycler view here. We have a lot of different currencies. We have quite frequent updates, like every 5 seconds we receive new rates from the backend, and we should redraw everything. Also, we have this animation when currency goes to top, uh, and it's also quite a tricky thing. To be honest, I stole this task once. I've been like I joined some technical interview. I don't remember their company which was interviewing me, and they gave me probably pretty the same task, and I decided to use it in our Rolling Scope school. Yeah, also I forgot to mention that Rolling Scope School and Mobile People are two big communities, friendly communities to Codberry. So feel free to join Mobile People and Rolling Scopes. We're creating a lot of educational materials and courses and have a lot of plans for the future. Yeah, but yeah,
so we will share the links under the video on YouTube, and you can follow the link and subscribe to different channels.
yeah. Thank you, Andrei. And let me hide this emulator and let's review the code actually. Um, First of all, let's review the structure of the project. We have a lot of different packages, we have resources, and also we have build files, build.gradle files, because Android project builds by Gradle. Uh, for the last I would say 8 or 9 years, because when I was started we used Maven, we used Ant and different systems, but now it's very like simple to use Gradle. We can add implementations, we can connect different libraries, write Gradle plugins, and we have a lot of different capabilities right now. Also, Android projects can use native code, I mean C++ libraries, like SO files and so on. In this project, we're using, of course, Kotlin, because Kotlin is like official Android programming language, and I would say that there are not a lot of projects on Java nowadays. Probably only some legacy stuff, but majority of fresh projects are created in Kotlin. And also we're using Kotlin coroutines here for asynchronous work, using libraries for JSON parsing, using OK HTTP and Retrofit, two libraries for networking. Also, probably guys from Java world will know Dagger. Dagger is dependency injection framework, and we're using it here. I would say that nowadays we also can use Hilt. Hilt is some kind of um, library atop of Dagger, and it adds some annotations to Android. But in this project, we're using like pure Dagger without any additional libraries. Uh, Working with life cycles, some KTX, we're using constraint layout. I will show it a little bit later, and some base Android core libraries, core KTX, Kotlin extensions, and so on. Okay, also we have settings Gradle. In settings, we're including different modules. As you can see, this app is really simple, and we have only one module called app, and it is included here. Okay, if we'll go to the app, src main, we can see that there are resources, res folder, and Java, but also in this folder we can find manifest file. And Android manifest is main configuration file of Android application. We should define users permissions here. For example, internet is used by this application, and when you're installing Android from Google Play, you will see that this application requires this permission. And also starting from Android 6, probably you should like allow permissions manually pressing this allow button in dialog. Okay, as you can see, we have application here. We will review this class. We have main application, and inside application we have activity. Activity is main component, one of main Android components, which represents actually single screen. And we have intent filter. Intents is some stuff in Android which represents some events with information. And actually, when user presses on the icon of your application, then this launcher intent will be triggered by the system, and your main activity, your activity with this intent filter will be launched. This is how Android decides how to run and which activity to run on start. Okay, let's go next. And next we will review main application. Probably it's application class. It has onCreate method. All Android components, main components, there are 4 base: application, activity, content provider, and service. Yeah. All these components. Oh, and broadcast receiver. Sorry, forget about it. 4 components. All they have some kind of life cycle when it is created, destroyed, paused, stopped. This lifecycle is quite complex, and probably you have to review documentation to understand how Android works and handles all these rotations of your screen, for example. But it's not in scope of this talk. In our application, we are initializing our Dagger app component through builder, providing application context. It is kind of base stuff. Using context, we can do a lot of things in Android applications. For example, get access to resources like string resources, images stored in your application, and so on. And basically, quite a simple extension function for app component to get this app component from context. Okay. Also, we didn't discuss this part with resources because probably it's also interesting. Nowadays, we have two approaches, imperative and declarative. And in this project, we still using XML layouts, but also you can find Jetpack Compose and composable functions and compose your layouts in code. Like in Flutter, for example, it happens, or in Swift UI if you're an iOS developer, and so on. A lot of different like alternatives. Okay, let me open one of layouts, and as you can see, this is currency item, which represents one single item in our list which we're displaying, and also we can open code and review that it consists of constraint layout, and inside this constraint layout we have image view, text view, and another text view and edit text, and we can actually see that we have image view which represents our image, text view for currency code, then text view for actual name of currency, and edit text it is used to like set other value, and also it is used to represent value of like current currency. Constraint layout is quite powerful, and you can see that we can place our components relatively. It means that, for example, this edit text constraint end to end of parent. It means that end of this element will be on the end of parent on the right side, and also constraint top to the top of currency code. So we're aligned by currency code top. I think you got like base understanding on how layouts in this application work, and let's review some other stuff. For example, drawable.
May I ask
Yep.
question
Yeah, sure.
related to layout? During development, you use a special visual designer for make this layout or write this XML manually?
Yeah, sure. It's not so complex. Actually, let's go to the main activity. For example, we have this list. We have some, for example, this is progress bar, and I can use this view to edit somehow. For example, I can move our text. I can move other components just by mouse. But usually, I'm using something like double approach. I'm checking the code because when you're using just graphical editor, you can get a lot of redundant lines in your like actual code. So yeah, basically you can use this approach or this approach, but I prefer something like a combination of two approaches.
Is it possible to write some XML not supported by Visual Designer, but
I
supported by device?
I think no. Probably Android Studio is a great tool, and probably everything will be displayed. Probably you can write some view stubs, which is stub for the view which will be replaced in the runtime, and in this case, Visual Designer will not be able to visualize it just because in runtime you should replace it with something, but with regular components, like this visual designer can represent everything. And also you can select a device, you can select like aspect ratio and so on, and
Okay.
even some themes and styles.
And one more question. Is it possible to register some components globally in Android operation system, or it's not possible?
Which components do you mean?
I mean, some
Main
visual
components?
elements, uh,
Oh,
probably
visual
set of.
elements.
Mhm.
No, it is not possible because all and like visual elements are bundled within the project, and you cannot share. Only fonts can be shared on latest versions of Android and stuff like this, but like main UI components on the same phone cannot be reused, but applications can communicate, and even applications written by the same developer, for example, can open screens of other applications with the same uh, signature, for example. But we should use like special mechanisms like AIDL and its Android interface definition language, and it is required for cross communication, inter-process communication between different applications. In Android, every application runs in its own process, and
Isolated.
this process is kind of isolated here.
Mm. Okay, thank you.
Yeah,
We
it
have a
is based on Java, and we also receive virtual machine, and virtual machine receives some like memory, and all this stuff is isolated for the process. But we have a lot of abilities for inter-process communication. Even intent we're discussing here, this intent we receive from the system application, because launcher is system application, and it sends intent, and this intent is received by intent filter, and it's kind of inter-process communication.
Thank you. Thank you for the answer. We have a couple of questions in our chat. Uh, so, first one, is it possible to share the GitHub of the project?
Yeah, sure, we can share GitHub after the session.
And next one question. We have a project, but written on Kotlin,
Mhm.
but main folder is Java folder. Why?
Okay. I would say that is something like inherited from old times, because not so long time ago we used to create Java applications, um, like Android applications in Java, and uh, actually it's not a problem to rename it. To do it, we have to modify this build Gradle file, adding resource adding code directories. Probably we don't have this section right here. Yeah, but it's quite simple. Just add here source sets, add your Kotlin directory as a source set, and then Gradle will understand that inside Kotlin folder, your Kotlin code lives. And also, you can easily create Java files right here in this Kotlin project, and it will still be compatible and compilable, because Kotlin and Java are 100% like compatible. And yeah, probably it answers the question.
So if I use Kotlin folder, Android Studio support it, or
Yeah, it supports it. Yeah, but as I and like told, it's not about Android Studio. It's about Gradle. Like we should set this Kotlin folder as source code folder for this project, and Gradle will see it. Probably in latest Android Studio it will work by default. Yeah, but I didn't check.
okay? And we have a couple of questions in our chat. Uh, mm, So why no one uses data bindings nowadays?
It's an interesting question because data bindings are not so um, comfortable to use, I would say. First of all, it's quite hard to onboard new developers to such projects, especially developers who didn't work with data bindings. I will show how this kind of architecture is implemented in this project. It is not actually data binding, but um, it is possible to use data binding right here. But in my personal opinion, it's better to store your parts of code with the code, but not mix it with like XML layouts. Uh, yeah, and also, as I remember, it was only ability to use Java code inside like XML layouts with data binding, not Kotlin code, and it was also not like popular throughout developers. And finally, more and more we have more and more popular Jetpack Compose, and uh, data binding is also not about composable functions and declarative UI.
Okay, we have a lot of questions in our chat, but let's continue with the content. After some time, we will
Yeah, sure.
return to
We
the
have a
questions.
lot of time. Yeah, probably we finished with this UI stuff, so I'm closing these files. And yeah, I wanted to tell you about drawable folders and why they're segregated by HDPI, MDPI, X and XX and XXX HDPI. Basically, we have different um, aspect ratios of devices, and what is even more important, different density. And depending on screen density, you can put your PNG files. For example, in HDPI, it will be this source, and for example, in XXX, the same will look in a different way. So it's two completely like similar images, but with different uh, like density, let's say. Also, it is possible to use vector graphic, and my personal approach is to use vector graphic in all places where it's possible, because vector images look smoother on all kind of displays, and this approach is kind of outdated. But we have really a lot of different flags and graphic in this project, so I think it's just for simplicity. Um, yeah, let's continue probably with values. And inside web values, we have strings, strings.xml file. And in this file, we can declare different strings for, and then we can use them by this key in your project. As I already mentioned, we can use context to get resources and get access to string resources, and by this key, we'll receive the string. Probably you can have a question how to make translation and localization and stuff like this. It's very simple. We just creating string resources, string files for different languages, like strings for English, strings for Russian, and so on. It's just it depends on the name of the folder it is placed inside. But in this project, we have only one values folder with strings for English. Yep, I think it's time to go and look through the code. Main application we already looked, but let's review structure of the project. Actually, we have some base. We have app constants here. It is base URL we're using to get our rates. As you can see, it's Google Cloud Functions, just like simple endpoint. We have time, like refresh rate. It's 5 seconds. So every 5 seconds, rates will be requested. And some base constants. Also, we have app resources. And that's what I was talking about. We can get string by name, and different overridings. And these methods basically duplicating functionality from context and inside implementation file, because it was interface and this is implementation of this file. We are using context and getting resources from context here, and from resources we are getting string resource. So why do we need to have this interface? And answer is quite simple: just to write unit tests and have more abstraction in our code. It means that uh, we can provide this app resources implementation as some interface. And this interface is easily mockable. We can write unit tests inside unit test, mock this interface and provide some mock object with some stub strings and check anything. And also inside unit tests, we're not allowed to use Android dependencies, for example, context. And if we have just interface, okay, no problem, just mocking this simple interface without Android dependencies. Also, you can see that we're using inject annotation, inject on constructor
Do
of
you
this
have
field.
example of the unit tests? I'm sorry for interruption.
Yeah, let's check. I didn't check. Okay, we should have app src. Probably we don't have tests in this project, unfortunately. My fault. Probably next time I'll prepare some unit tests to show. Yeah, but let's return back to dependency injection and inject annotation. It is actually not from Dagger, but from GSR specification. I don't remember the number. It's JavaX inject, and by this annotation, Dagger knows how to create this resource, because it can see that it requires only context. Dagger can then check if context is available, and if context is available, then this resource will be built and provided. And also, we should provide this resource as app resources, as interface. And to do this, we have dependency injection folder and app binds module. And you can see that app resources implementation is provided as interface app resources using this binds annotation inside the Dagger module. That's how it basically works. Yeah, quite a common and simple class, which allows us to get access to drawables and string resources. Also, we have inside base ViewModel factory. Let's probably skip it. It's quite complex, and I can just say that it is required by Dagger to provide dependencies to the ViewModel. And we'll talk about ViewModel a little bit later. Also, we have data folder. Yeah, I should mention that in Android, it's very, very popular to use clean architecture. And that's why we have data, domain, and UI layer. Also, UI sometimes can be called presentation. So presentation, domain, and data layers. And by the clean architecture, we should have for example, we inside domain layer, we shouldn't have dependencies to data layer, but it is allowed to have dependency on domain layer from data layer. I think you can easily find this circle of clean architecture. By the way, it's interesting. Is clean architecture also popular in front-end world? Andrei, could you? add something.
So I've read questions and probably missed some context.
Yeah.
So we have a lot of questions related previous topic about the visual part of the application. Uh, could you please repeat your one
Okay,
question?
sure. Yeah, I was discussing that. I was talking that we have data, domain, and UI or presentation level layers in our project by the clean architecture. And clean architecture is very popular. And if you'll Google clean architecture, you'll find this famous drawing with circle, different layers, and dependency flow. Um and my question was, is it also popular in front-end world?
I have no really one answer for your question. We have different models for working with visual part. Sometimes ago we had model view model pattern in our front end. For now, we have a lot of application with Redux Flux pattern. It's similar to CQRS from backend, I would say. Uh, Sometimes we have something like mess with logic and visual part. We have no strict rules for front end. We really different frameworks implement these concepts in
Mhm.
different ways.
Yeah, I got it. Thank you. But actually, in this application, we are using MVVM with ViewModel, View, and it is placed on UI layer. But clean architecture is a little bit wider, and it's also about domain layer, communication with repositories, and so on. But let me proceed. Um, on data layer, we have um, API service, which is actually backed by retrofit library. It is quite easy. We declared two suspend functions, get currencies and get currency by date, and it is not even used, as you can see. So we're using just one this, and this function returns list of currencies. As you can see, it is marked with suspend keyword. It means that this function should be called from coroutine or from other suspend function. And you can see that it is marked with get annotation. It means that it will make a get request to the endpoint with currency path and will return the list of currencies. Also out of the box, it should parse currency. And here we have the model for parsing of currencies, and you can see that we're using serialized name for date, rate, and base. Yeah, it's quite hard being Android developers and working with Java just because you cannot just get some JSON and call fields from this JSON. You should serialize it, parse it, and then use. Okay. Also, I should show you dependency injection API module. You can see that inside API module, we are providing a lot of different stuff. Dependency injection framework Dagger can provide dependencies by three different ways. First way, we already saw here in currency repository. We're using inject annotation on constructor, and it is the most preferable way. Second, we also saw it is here in binds module. We can provide something like app resources, for example, by binds annotation, and like using this approach, you can provide some interface, not interface, but actual implementation somewhere where interface is required. And third way, like probably there are more ways, but these three ways are like mostly used across different projects. Yeah, and this is third way, where I declare a function, marking it with provides annotation, declaring that we are going to provide something. Also, we can specify the scope. Scope singleton means that this object will be accessible during the lifetime of like the app. And this approach should be used in case when we need some configuration or, for example, calling builder pattern and build an object before returning. We cannot just provide a constructor and inject, but we should actually build something and then provide. Here we have some logic depending on build configuration and providing like HTTP login interceptor with additional levels. Yeah, and in this module, actually, we're providing retrofit instance. We're setting base URL from constants. This cloud functions URL you saw. Then we're providing OK HTTP client. It is client provided lower. We're providing converter factory. Probably you remember that in our API service, we're receiving currencies, and these currencies are already mapped to like actually currency. So someone parsed everything for us, and actually it was this converter factory. So we're using JSON converter factory and creating it right here. And finally, providing API service here. That's basically how dependency injection works in the whole project. Okay. And as for the data, we also have this currency repository, and it's quite straightforward. Repository implements interface, and interface is stored on domain layer. As you can see, it is here. We are doing this just because domain layer should know nothing about data layer. But on domain layer, we have interactor, and this interactor wants to use repository. And to do this, we're declaring interface of currency repository on domain layer, and data layer just creates implementation of this repository and provides it using inject annotation. And also, as you remember, we have inside dependency injection, we have this binds module, and we are also providing it as currency repository interface to be accessible. Okay, but what happens inside this repository? Let's check. Actually, we have two states. Is obtain, like is obtain flag by default is true, but when someone calls stop obtain, it is going to false, and we're not updating anymore. Actually, after calling this function, we're returning flow. Flow is something like observable. Probably most of you should work with observables previously, and actually we're creating this flow here. And inside flow we have while true cycle, and inside this cycle we have check for is obtain, like it's just switch, like turn on, turn off. And currencies are received from the repository and then emitted. Emit means that we're emitting values received from the repository to the flow, and all flow subscribers should receive this update. And actually we're making delay, and that's how we're sending updates every 5 seconds, because this time to refresh is 5 seconds. Yeah, quite a simple piece of code. And also I should say that this is a called observable, because it will not work before we like we should actually launch it, subscribe to it to make it run this code.
Can we
And
use something like RX Kotlin or RX Java for make
yes,
this?
yes, sure. We can use, and I will say you more. We used to use RxJava. Uh, like for quite a long time, RxJava was a standard in Android development, but right now we have Kotlin, we have flows available out of the box without unnecessary dependencies to the project. So I'm basically think that we don't need RxJava anymore because Flow provides pretty the same set of functions. Map is easily available, like flat map and all stuff you need. Believe me.
And Flow, it's a independent library, or what does it mean?
Yeah, Flow is part of Kotlin coroutines,
Ah, I see.
as you can see, and we Kotlin X coroutines Flow, and as we're using coroutines in this project, then it's good idea to use Flow also.
Okay, thank you.
Yep. Yeah. Thank you for your question. It's a really great question because yeah. Uh, let's go next. Next, we can go to the domain layer. On this layer, as you remember, we're using we have interactor, or sometimes you can have use cases here, and we can have use case for every specific like action. And but here our app is not so big, and we have just one interactor with like subscription to this flow. Actually, we're using currency repository from previous file, and we're providing this function get UI currency stream, and it returns flow, but please note that it returns flow not of currencies but of UI currencies. UI currency is special model for UI layer which has image ID, description ID, code, and value. Basically, having all these on UI side, we can easily build this uh, single element. Let's see, we have catch block for handling exceptions, and in case of exceptions we are emitting empty list here on this stage, and we have map function here, and in this function we're mapping these currencies from received from currency repository to our UI currencies inside this map server data to UI function. It is placed in interactor utils, but anyway, yeah, here is it how it works. Basically, just transforming one to another. And finally, we have flow on operator, which runs everything, and we're setting dispatcher here is dispatcher IO. And duplicating repository start obtain and stop obtain to have this functionality here. This interactor quite a straightforward, and I don't think that we should stay on it. So let's go to the UI. As I already mentioned, on the UI layer, we're using MVVM pattern. We have ViewModel, and in Android, we have special library. It is called ViewModel, but actually, it is not a ViewModel from MVVM. It is just something which allows you to survive during screen rotations, let's say. Because in Android, like the most important problem is when you rotate the screen and you have like screen rotation enabled, then all your screen will be recreated, all stuff will be deleted, and everything will be created from scratch. I mean, this activity. But view model can have some state, and this state will be stored during this rotation, and then a newly created UI can request the state again and redraw. As you can see, we're using stateflow here with screen state, and let's see how it works. In start receiving data, basically probably this method is called from the UI. Let's check. Yeah, from main activity. I should say that here in this project, activity is used as a main screen, but in majority of modern projects we're trying to use fragments. Fragment is something like a representation of one screen, but also we can place several fragments on one screen. For example, on tablet you can place several screens because it has a lot of space, and it's possible to do it using fragments. But in nutshell, fragment is quite a lightweight, like much faster than activity. I mean, it's easier for the system to create fragment. That's why we're trying to use fragments instead of activities. But here we have only one screen and there is no need to create fragment. So let's review what's going on here. We have activity main binding. Yeah, you were asking about data binding previously, but we're using activity main binding. It is not data binding, but view binding. It means that we're getting this link to actually our view, and inside this binding we can have like links, references to the like actual views. It's quite easy. So we just during registration we're just calling activity main binding dot inflate, providing layout inflator and initializing this binding, and then we can use different fields. Like here we're using recycler view from this binding. Yeah, previously we used to have a lot of different fields like representing every view, and we had to initialize every view here using find view by ID functions. You know, it's quite a boring routine when you have like 10 different views and you have to write find view by ID, r.id, and so on. But currently it's much easier just using view binding. What else? We're setting content view as binding root, initializing UI data. Basically, we're just initializing recycler view, its view with this like main view when you're scrolling these items decorator, fixed sized, and observer, and initializing collectors. Inside collectors we're using lifecycle scope. Yeah, as I already told you, Android has special lifecycle, and all components have special lifecycle, and we should be careful. We should subscribe and unsubscribe when lifecycle changes. So we have a lot of different helpers, and such kind of scopes is very like useful. We're launching ViewModel flow with lifecycle, providing this lifecycle state. Actually, we're telling that this flow should run when state is started. So only after activity is started, we can like run this flow. And collecting data and calling handle method. It is reference to the function. And inside handle, we're receiving some screen state, and depending on state, we're showing error or loading or showing currencies. Basically, it's quite a straightforward. We're getting some state from the view model, and we're like drawing this state. For example, show currencies will like hide progress bar, hide error message, will show recycler view, and submit list of new currencies to our adapter. And also if base rate changed, adapter will handle rate change. It means like when new item should be added on top. Probably you remember. And a lot of helping functions like show loading, show error, and so on for drawing and changing state. So view is quite straightforward. Probably I should mention that we're using inject annotations here to inject ViewModel factory by Dagger, and app resources also injected here. And that's it. Also, quite an interesting part is here in Kotlin. We have feature called delegates, and using keyword by, we can delegate creation of adapter to lazy delegate. It means that it will be initialized lazily. And also ViewModel delegated by ViewModels, and it will be also initiated by the request by ViewModels from the ViewModel factory, which is injected here. I know that it can look like hard stuff, but actually it's not so hard. Inside the ViewModel, we're handling events from the view, for example, on item right click, on different events like start receiving data is also like triggered from the view side. And we're just calling start API, and this flow in Interactor will start running, and subscribers of this Interactor will start to receive updates. Let's see where it happens, and it happens in get currency function, and it is called here in onCreate. Basically, when our onCreate is finished, we're like as a last function, we're calling get currencies here, and inside ViewModel scope, we're launching this interactor, getting UI currency stream, handling exceptions, and collecting latest values. That's basically it, and then handling, of course. If everything was successful, we're providing screen state success with currencies received and with base rate and so on, and some helper functions. Yeah, but basically there are a lot of different logic here. I don't think that it will be useful to review every line of code, because we're just having basic review on how this stuff is working. And finally, we have this factory, and we reviewed this base view model factory at the beginning. It is used to provide it to the activity here. Okay, what else do we have? Probably just currency codes. Okay, it's small enum with currency codes, nothing interesting. And some utils. We already reviewed this mapping mechanism, but also we have here what? Inside initialization block, we are initializing UI currency map. It is hash map, which contains string as a key and pair of integers as a value. And actually, it is something like mapping between currency code and drawable and string. Yeah. So nothing special and hard. Okay, Andrea, I think that we're pretty done with the code review. So let's proceed with the questions.
So we have a lot of questions in our chat, and feel free to
great.
add more questions. We have comments that our get currencies looks like so we make request every 5 seconds. is it possible to optimize this interactor and mm, make it more smart?
Um, uh, Sorry, I had some network glitch and didn't catch there.
So,
Like, what's the problem with Interactor? Yeah.
not with interactor, with our get currencies method, where we make request every 5 seconds.
Oh, here. Yep.
Yeah, yeah,
Probably get currency stream. Yeah.
yeah.
Okay. We're getting request every 5 seconds, and the question was how to optimize it.
Yeah,
Hmm.
it's
Okay.
question
I
from my side. We have just comment in our chat.
Okay. Actually, I don't see the idea. Actually, we're using coroutines, and here you can see that it is call of suspend functions, and suspend functions are not blocking. It means that uh, thread will be released during like waiting time, let's say. Also, this delay is not blocking, so during delay, working like thread will be also released, and we'll proceed maybe on some other thread later. What else? While true, obtain every 5. Yeah, we just had such kind of task to get um, information every 5 seconds. So I don't see how to optimize it.
Okay, let's skip it. We have a questions related to compose. What do you think
Mhm.
about compose, and why we don't use it here? Is it useful, or what do you think?
Yeah, sure. As I already told, we today we're reviewing not cutting edge project, but like modern project, uh, like on such project we're usually working on daily basis. And as for the compose, it's quite a new, not new, but fresh technology. I think it has good chances, and I expect that it will replace regular layouts in the future, but we should give it a little bit more time, actually. But as a technology, it is great. I also used to work with Flutter, and but I see that Flutter developers don't have any issues with their code. Of course, Compose is a little different, but like the main concept is the same, and composable functions are the future. And that's why, for example, in our mobile department right now, we're developing educational course about Jetpack Compose and how to use it actually.
We have question: is it educational uh, example, or how close it to real production code?
Um, it is educational example, I would say, but it's not so far from production code. Uh, actually, I would love every production project would look something like this, because sometimes you can find a lot of legacy stuff, and um, I would say that in production, we're using flows, for example, we're using the same segregation. Probably a real production project will be much bigger. It will probably have not only one module, but multiple modules with cross module dependencies, with harder dependency injection mechanism, and so on. But in general, it is pretty near the production.
Okay, thank you. So we have a lot of questions, not a lot, but some of question related to code and some suggestion. I think we will answer in in the chat or under the video in comments. Um, so as I can see, list of questions what I'm going to ask already over, and we can finish our stream.
Yeah, sure.
Thank you.
Thank you so much.
Yes, thank you. It was interesting. It's really cool. So, thank you all for who was with us. Feel free to follow our uh, community in Telegram and on YouTube. And have a good day.
Yep. Bye.
Bye.